This is the third NoSQL model that we'll be discussing. Okay, so a little recap. I think this is easy. This is what we already, okay, this is what we already know about, right? We do have the relational model. We do have all the other 4 NoSQL models that we've been looking at. And key value, we already discussed. Document, we already discussed. Now it's the time for column family and graph model. So let's look at first column family. Another terminology that some maybe store some database engine, okay, and also maybe some articles may refer to column family model, could be columnar model or wide column model, okay, and as we used to discuss so far, relational model is by far has gained popularity, has established standardization in terms of the query language and also even many other things, right? But if we talk about other NoSQL models, there are not yet such a kind of well-established standardization, either in terms of query language and operations, as well as in terms of the even sometimes the terminology or sometimes the operational implementation and so on, okay? So it could be as well that if you read and study some other specific engine and store, you might have found different terminologies, explanations, and implementation, okay? So what my explanation and what we will discuss here about columnar, column family, or whatever, many different names, basic concepts are the same, but even the terminology to refer to some specific concept may be varied, okay? What I would refer to basically are based on Apache Cassandra, because it's considered to be one of the most popular column family stores, okay? And one of the very first column family implementation too. Okay, anyway, let's look at some key concepts related to column family model. Again, it is a kind of enhancement to the very first basic concept of NoSQL that is based on key value. But of course, both document model, column family model, they kind of enhance key value model in a way that additional structures, more complicated structure, enhanced structure have been introduced because key values are too simple, right? And it has a lot of limitations to handle more sophisticated structures rather than just key and then anything is regarded as value. So we want to use the concept of key and then whatever that is considered as value, we constrain, we put more of the structures into it. So that is the basic of how enhancements have been made. And the very first and most influential concept of column family was initiated by Google's Big Table. Okay, and with the reasons, of course, with the reason to handle huge amount of data. Of course, we already discussed, right? NoSQL has been widely used and has become popular because relational model itself has certain performance and scalability issues and so on. So based on those of the big data concept, right, that brings more of the data in a various structure, right, variety of structure, volume, and velocity, and so on. All those V, right, that we discussed, those are the 4V, 5V that lead to development of new data technology. Okay. And not only Google Bigtable, right, but other widely used sources include such as Cassandra, HBase, Hypertable, Amazon, DynamoDB, and so on. But keep in mind as well that nowadays it's not like one data store technology or engine. It's not to be said like, hey, I am just column family technology tool. I am only document store system. I'm only relational model system. Nowadays, several of these engines try to integrate more of the capabilities to handle more structure, okay, various structure. And there is no kind of pure, completely single technology that is behind the implementation. Several of the current engines try to integrate a few of the technologies and become more capable of handling more than one type of data model. Okay, but of course there could be some trade-off that is more focused on this specific model than the other, but add some of the capabilities in some additional structures too. Okay. Okay, let's have some understanding together first. In most, when we talk about our preceding technology, which is relational model, we use rows as a unit of storage. That is, you have a table, and for sure, the table structure or relational structure has, of course, column and row. But when you do a kind of manipulation to the data, insertion, handling the data, and so on, right? The unit of data, unit of storage would be a row oriented. We more or less say that we insert a new row, we delete the entire row, and so on, right? Or we filter data based on certain attributes, but of course, when it is retrieved, it is a row-oriented retrieval anyway. So in relational model, row is a kind of unit of data that we refer to. And it's very good in terms of writing performance. You write one row at a time, most of the time, right? We write one row into a database table, insert a row, update a row, and so on. But there are certain use cases and needs as well that sometimes we may not want only row-oriented operation, but we may want something like column-oriented operation, especially when it is about reading, such as you may want to perform certain kind of analytical process. We may want the entire column to be retrieved, we may want to calculate kind of aggregation, right? Aggregation query and so on based on an entire column. So in that case, a column-oriented operation would be more efficient and more straightforward for those types of tasks. So with these demands, to optimize access and read, it could be useful and efficient if we consider a group of columns in which we call a group of columns. That is why we call column family, because a group means a family of related columns. Okay, a group of columns or family of columns, or in other words, column families could be treated as storage units. Okay. So with the column family model, it means that columns can be grouped to a so-called column family. And of course, these can help support organization and partitioning of data in a column structure. And this is what we already mentioned. Each column, of course, again, is considered as a pair of key and value. That means for sure this is a key. A column name is considered as a key, for example. A column value is considered as an associated value associated with that key, right? And it has an additional field for kind of controlling several updates into the column value in terms of the timestamp. It will include as well that this value has been last updated in which during which timestamp. So if we look at a wider picture, bigger picture, we will see that for each row, we will have something which is called row key. So this is the whole, the key that refers to everything as the associated value. So it is the key of a row, the whole row. So still, this allows us to retrieve the entire row of a certain data, because somehow the entire row still have the very important meaning, right? It groups all those columns together. Okay. And each column would have its own column name, column value, and timestamp. But we do have several of the column name, column value, and timestamp for each row for sure. Okay. And we can have another example here. This is kind of basic structure of one particular row. But it could, of course, we don't have only one particular row. We have several rows of certain data, right? So let's give an example that we want to store data about user profile. So for a user profile, it could be that we have a row key. This is the row key, a key for the entire row. Each row would have different columns, such as for this row, it has 3 columns: email address, gender, and age. Of course, the column has associated value plus timestamp of that value. And different rows. So this is row number 1, right? Row key Bob, row key Brittany, row key Tori. Each row, of course, this is a thing that is very different from relational model in the way that we don't have fixed schema, right? It is not schema full. It is schema-less structure. Different rows may have different columns. No fixed structure. But of course, there could be that similar structure are there, such as these two. They seem to be very similar in terms of the structure, right? Except that there's no edge. But if we look at this one, we can see that it has more variety. It's more different. It's become different from the others. And this is, of course, the nature of NoSQL model, right? Can it have two values? Then you need two columns. And let's look at the structure of column family, physical structure, the conceptual structure, but in a way that the column family are organized. But again, as I said, most of these terminology we refer to here are very much Cassandra-based ones. Different store, they may introduce or refer to their own ways differently, but of course, conceptually could be the same, but they may use different terminology. Okay, so we will have what is called key space. Inside the key space, we can have many of the column family, but let's look better in a bigger picture. In each key space, of course, we look like this picture, but each column family, okay, could be viewed in this way. You zoom in this one, okay, we get a view of this one. So one key space comprises many column families. And each column family comprises the structure that we already discussed, that is row key, column and column name and value pair. For each row key, it comprises this structure. So that is why you could see this is one particular row. Can be row number 1, row number 2, and so on. And each of the row could have different structure because it is the NoSQL, right? Okay, so if as I said, I zoom in, you could see that there's a row key, number 1, number 2, and so on. Each of the row would be associated with different or same column, name, and value, and so on. And we could have another family within the key space, and again, they would have different of this structure of the columns and so on. And you could group the key space. I mean, these two column families belong to this key space. There could be another key space and so on. And depending on which column family store you are using, instead of providing only this kind of structure that we already looked at, another complicated, also more sophisticated structure could also be provided for the developer and database model, in which instead of one column name associated with a value, it could be that we group several of the columns together into what is called super column, such as, I would try to guess, okay, to think of one, some example use case. You may think of super column name as contact information, or even just one local smaller concept as address. Inside address as a super column name, you can have street name, city, country, zip code, or something, right? Those are some examples, but there could be more than just this. So it's kind of grouping several related columns together into a super column family, a super column, yes. And then, yes, we do the same. That means super column family can have something like this. A row can have many super columns, okay? And inside each super column, you have column and you have column name and value, column name and value. And of course, this is to simplify a little bit by omitting the timestamp. But most of the implementation would include timestamp as well. So this is another example of the model using super column family. This could be an artist, Billy Bragg. There is a super column for personal details, which could include the date, year he was born, the nationality, the user base information, right? And so on. So it could be more. And it could have another super column, which is related to maybe an album that he released and so on. And could be some other, this is just a column, not a super column. So you can mix whether with this super column family structure, you entirely have several super columns, even mixed with single column structure too. Okay. And as I already mentioned, this is no sequence structure. Whether you have a very fixed, rigid schema or structure, which is fine. You can restrict yourself to have very fixed schema, or you can have a very flexible schema, which is kind of dynamic. Not meaning that you don't restrict that every row must follow the same structure. Okay, it's the same as document model, right? You can fix that all the data should have the same schema, or you actually make it very flexible because you want to allow more of the flexibility into the data model. Okay, so when it is a fixed static column family structure, you could see that we can fix that every row must have name and email. And some could be some optional, or we can make it very dynamic that we put no restriction at all. So it is freely updated by the user and so on. So in summary, in column family, column family store and model, there could be a concept what is called key space, in which they are kind of container, top level container that hold the column families together, right? And for each column family inside a key space is of course another container, right? Which store row keys and column families. And the row key is what is considered as similar to the concept of key value. Is the unique identifier in which it used to refer to and identify the data that is stored within the column family. So you could retrieve the entire column associated with that particular row key. We could either have both super column or column, which is a kind of aggregation or grouping of many columns together if it is super column. okay? Or it is a single pair of name and value, column name and column value, okay? And again, timestamp is mostly there as well to identify that which particular time the value has been updated and available. So a little more information and comparison. Now we can see that there are two, not really opposite in the way that even with column oriented, we still operate something based on the row as well somehow, okay? But there are really different types of operations in which we want to perform based on row-oriented operation or column-oriented operation. In most of the relational database operations, everything will be referring to rows as a unit of storage. And in that case, writing performance could be optimized as well because we write one entire row at a time. When it is retrieved, the database system also retrieves particular block of the entire row at a time as well. So writing could be easily handled. However, for certain scenarios or use cases, if writes are rare, if you have application requirements, for example, that you may not require a lot of writing, but you perhaps want more of the reading. And in terms of the reading, perhaps we want to read certain columns, few columns at a time, maybe kind of column-based, column-oriented operation is more appropriate. Okay. This is an example of how do we separate or consider these different row-oriented versus column-oriented. Okay, in which we may be interested in considering certain entire columns at a time. So benefit of column-oriented would be on fast data aggregation based on a column, such as I already mentioned, when we talk about aggregation, it's kind of summary of the data based on single column, right? So it could be providing summaries of the data such as average sales value. So when we talk about average sales value, we are talking about just one single column sales, right, of each of the order. Suppose it's the data about sales order, in which you have date, you have total sale amount, you have many others, but more or less we may consider just the sale amount of the single month, right? We may want, or single year, we may want to do a number of OLAP operations, okay, data warehousing related operations and so on. You are interested in just aggregating all this data. In terms of reason or use case in Google use cases, they are interested in, of course, statistics about web page visits in a year, a month, or a quarter or something, right? Number of times the website has been visited and the data that has been archived are related to such visits. So these are kind of column-based operation that may be required in various different applications and use cases. And another thing is that if we talk about transaction data, mostly transaction data means you frequently have, right? Read may be rare, right? Depending whether there are more of the reading query or not, but write could be more often. So with transaction, write and update of the data could be the most frequent operations. And that means it may require row-oriented operation to update particular row. But when write is rare, such as based on analytical data store that, as I said, perhaps for like data warehouse, maybe data lake, maybe many other things that they just dump all the data for aggregation purpose, analysis purpose, and so on. They never update, okay? They rarely update. Bulk write could be there. And that is where perhaps column family or column oriented operation could be a suitable solution. Okay. So row oriented comparison, row oriented database, perhaps it could be more suitable for transaction processing system. For column oriented, could be more suitable for analytical processing system. And I refer to this additional resource in which you may be interested in reading more of a case of Cassandra. Okay. And with this case study, it also demonstrates that when we want to model certain data source, the suggestion of the analysis and modeling is very much query-driven approach. So that means very much driving from, as I mentioned in the previous consultation time that I had with many of all of the groups as well, is more on the modeling of the data, appropriate data structure and model based on queries, usage, scenarios, or requirements. We model our data model by concerning what queries, what operations the system needs or you need for your application and system. Okay, I think then this is all about the column family.